Good morning, students. Today you get to hear my voice instead of Sal Khan's as we review graphing two variable equations. So the nice thing about two variable equations is they look really similar to the equation y equals mx plus b. And when I say equations, I mean inequalities. So in order to graph this type of inequality, we need to make it look as similar to y equals mx plus b as possible. So one thing that we always remember about y equals mx plus b formula is y is by itself. In this equation, or in this inequality right here, we do not have y by itself. I'm going to go ahead and circle our part of the equation with y, or part of the inequality with y, so we can remember that this is what we're trying to isolate, so we can find the slope and the y-intercept. So I'm going to go ahead and start by getting this variable. I'm going to actually rewrite the equation right here, or the inequality right here. And then we're going to go ahead and solve this inequality for y. So we're going to add 9x to both sides, and that gets the 4y by itself. So we're left with 4y is less than or equal to 9x plus 8. But we're not finished, because we need to get rid of this 4 that's in front of the y. Well, when we have a number in front of a variable like this, it means 4 is being multiplied by y. And what undoes multiplication? Well, it's division. So we need to divide by 4y, or by 4, not by 4y, to get y completely by itself. So the 4's cancel. I'm going to rewrite it over here. And we are left with with y is less than or equal to 9 over 4x plus 8 divided by 4, which gives us 2. So now it's really easy to graph this because we can see our slope is 9 over 4, so this is our slope, and then we can see our y-intercept. So remember, to graph an equation like this, we need to go find our y-intercept on the y-axis. Our y-intercept is 2. I'm going to use a different colored pen. We're going to draw a point right there. So we have our point at our y-intercept, and now what we're going to do is go up 9. So this is going up by 2. So we go up 2, 4, 6, 8, 9. So we wind up halfway between 10 and 12. Then we're going to go over 4. So this is again going by 2, so we're going to go over 2, 4. And make sure it's aligned with this right here. And we're going to go ahead and draw that line straight through. This all matches up just fine. And it's going to be a solid line because it is less than or equal to. So what I'm going to do to make sure that we understand where we're shading is I'm going to choose a test point. I'm going to choose the origin as our test point. So I'm going to plug in 0, 0. And if 0, 0 makes this inequality true, that means that we're going to shade this side of the inequality. If 0, 0 does not make this inequality true, then that means we're not going to shade this side of the inequality. We're going to try and see if the solutions on this side make the inequality true. So y is less than 9 over 4x plus 2. So I'm going to plug in 0 for x, and we are left with 0 and 0 for y. 0 times 9, 4 plus 2. We get 0 is less than or equal to 0 plus 2. So we get 0 is less than or equal to 2. This is a true statement. So we can see that this point, 0, 0, is included in the solution. So we're going to shade below the line to show that all the points less than y, or all the points less than 9x over 4 plus 2 are included in the solution. So that is one thing to note. All points less than 9 over 4x plus 2 are included. All right. Then we have some notes. I'm going to upload a photo of these in the PowerPoint so you guys can copy them down after you watch the video. So we have our notes where when we have greater than or equal to or less than or equal to, we have a solid line to show that the points along the line are included. And when we have just strictly less than or strictly greater to, we have a dashed line to show that those points are not included. So we'll do another example where we have it. All right, so we're now going to go over this next one. I'm going to go ahead and start by putting this into y equals mx plus b form, because as you notice, it is not currently in y equals mx plus b form. So let's get the y. Remember, we are always trying to get the y all by itself. So I'm going to go ahead and just circle it to remind us that this is what we're trying to get alone. So we're going to add 3x to both sides. We are left with negative 4y greater than or less than or equal to 2 plus 3x. Okay, I'm actually going to rewrite this so it more closely matches. Actually, you know what? I'm going to leave it. So we need to know that we can find the slope and the y-intercept, and the order doesn't matter. It matters which one has the x and which one does not. All right, so we're going to go ahead and divide by negative 4. And remember, when you divide both sides by a negative number like this, you are left, or you switch the sign. So we get y is greater than or equal to negative 1/2 minus 3 over 4x. All right, so we can see our y-intercept right here, and this is our y-intercept. And this right here, our negative is included in the slope. So don't forget to include the negative when you're finding the slope. It's the slope. Okay, so we're going to start negative 1/2, which is going to be probably somewhere around here. And then we are going to go down 4. So 1/2 to, let's see. So this is going to be a little tricky because we're starting from a half, okay? So we need to go 1/2 to 1 1/2. So we're going to be here. And then we're going to go 1/2 is probably around here. 2.5 is here. 3.5 is here. 4.5 is here. Okay. So it's confusing, but don't let those fractions throw you off, okay? Then we're going to go over 3. So that's pretty straightforward along the x-axis. We just go over 1, 2, 3. Then we can go ahead and graph our line, solid point, solid line because it is a solid line, or it is, what is the word? It's a greater than or equal to sign. So because we can see here that y is greater than negative 1/2 minus 3 over 4x, we are going to wind up with y being on this side. So I'm going to shade this side. All of the values on this side of the line are solutions, and we can test that with the origin. So we have 0 is greater than negative 1/2 minus 3 over 4 times 0, so that cancels. And 0 is indeed greater than negative 1/2. So we know that the origin is a solution, so it is included in the solution set. So y is greater than or equal to negative 1/2 minus 3 over 4, and this is how you show that. All right,